Good afternoon, everybody, and welcome to the 28th Hydrogen and Fuel Cells Europe exhibition here at the Hannovermesse 2022. We are at the public stage, and therefore I would invite you, the public, to come take a seat here. We still have some seats left, and the audio gets better the closer you get to me, so I invite you to do so. I will be talking about an interesting topic, the Kawasaki Hydrogen Road, the development of innovative hydrogen technologies. And for this topic, I want to invite to the podium with me Dr. Nurettin, Tekin, the Hydrogen Project Manager for Kawasaki Gas Turbine Europe. Please give him an applause. All right, Nurettin, welcome on stage here.
Thank you very much.
So, Kawasaki Gas Turbine Europe. I am so sorry to say this, I'm probably not the first one, but when I think of Kawasaki, I see motorbikes and not necessarily anything that would fit in on this stand, and unless it would be a hydrogen motorbike. But as I understand, that's not what you're doing. So, Kawasaki Gas Turbine Europe, what's it about?
Yeah, you're completely right. And sometimes people do like this, and we know that this is mostly the first and only association with Kawasaki. But we as Kawasaki Heavy Industries and Kawasaki Gas Turbine Europe, we are manufacturer, of course, of these fabulous motorbikes. But besides this, we have a lot of different technologies. And starting from, our origin comes from the shipbuilding, so we are manufacturer of big LNG tankers and manufacturer of trains, robotics, precision machineries, a lot of different technologies. And we as Kawasaki Gas Turbine Europe, we belong to the Energy and Plant Engineering Division, and we are located in Frankfurt am Main. Or let me say, we are located in Bad Homburg, next to Frankfurt am Main. So it's not so far away from Hanover, roughly 300 kilometers. But with this, at this location, we are responsible for the whole European market, parts of Middle East and North Africa. So we have a huge market in our responsibility. And our main products are the gas turbine, of course, and also beside gas turbines, gas engines, and we are providing engineering, service, maintenance works, and so on, all of that at this location. So we are a Japanese company, but we are very close, much more close to you than it seems.
All right. I think we'll get back to those gas turbines in a bit, probably. For now, I would like to focus on the topic of this talk, the Kawasaki Hydrogen Road.
Yes.
What is the Hydrogen Road?
Yeah. This is a good question. This is a, let me say, very special special approach. The road, the idea behind the Kawasaki Hydrogen Road is a worldwide import of huge hydrogen amounts to Japan. So the idea itself, it sounds very simple, but to realize this is very challenging. And so huge imports of hydrogen in terms of in kind of gasified hydrogen, in kind of liquefied hydrogen, is the focus of this road. And to realize such kind of huge import of hydrogen, you have to consider the whole supply chain or the value chain of hydrogen. And we did this, and we developed for each link of the supply chain. It is also visible on the small screen here. We develop for each link. This means starting from production, storage, transport, and utilization of hydrogen. And for each of these links, we have developed a lot of different products. and we have our own liquefied systems by Kawasaki Heavy Industries. So the starting point of this huge worldwide import is Australia. And the hydrogen is produced by gasification of brown coal. So don't be afraid. It's based on fossil fuels, but only at the beginning. So the brown coal will be gasified, and then with the CCS technology, with carbon capture and storage, the CO2 will be stored under the sea ground in Australia. So in the first stage, we would like to produce blue hydrogen, and this hydrogen will be liquefied in Australia. We have already liquefaction facilities there, and this hydrogen will be transported with ships, overseas ships, which is also developed by Kawasaki. So we have developed the worldwide first liquefied hydrogen carrier for overseas transportation. And this ship will arrive at the port of Kobe. This is the first pilot and demonstration terminal which is built there. And and we have also built in Kobe, at the port of Kobe, the worldwide first CHP application. This means combined heat and power application for 100% hydrogen. So all products, or most of the products, are already developed. Some of them are in development. So we have a very, let me say, unique selling point. We consider all of them, all the products within the supply chain.
The full supply chain.
Yeah.
Okay, I think there's a lot to unpack there. So let's start with the basics. Why does all this hydrogen need to go to Japan?
Yes, yeah, this is a good question. Yeah, you remember the Fukushima catastrophe 10 years ago, and after this catastrophe, the Japanese society decided to phase out of nuclear. So a big portion of energy supply in Japan is based on nuclear. So they took this decision after Fukushima, and you can imagine Japan is a small island with a high population, and so there is no room for massive installation of renewables like wind and photovoltaic. So the space is limited. You have high population, so to decarbonize their energy supply, so they have to go with hydrogen, and so they focus on that, and therefore they have developed all these products. So,
all right. So there's not enough room there to get your renewable energy, so you
Yes.
have to import all this energy, and it's
Yes.
actually the only way would be hydrogen then, I guess. Okay, and then we're going to go to the start of this whole value chain, or this hydrogen road. So we're in Australia, where brown coal is gasified.
yeah.
Is this done by Kawasaki? Where does Kawasaki get in the picture?
So within this road, of course, we are cooperating with a lot of different companies, and we have partners, and especially the gasification itself. This was not done directly by Kawasaki. It was done by our Japanese partner. It is the company J-Power, which is one of the biggest energy supplier in Japan. So they took this part for gasification, but the liquefaction is done by us, by our own technology.
And that happens there as well on site?
Yes.
Okay.
Yes.
And then the next step. So we got the brown coal, then we made hydrogen, liquefied hydrogen. We got liquid hydrogen. Where does it go? What's next?
From this liquefaction facility, the hydrogen is transported to the export terminal. So in Australia, in Hastings, Victoria, it's a terminal is installed, and from this terminal, it is loaded to our ship, which is also built by us. So as I said before, it's a worldwide first liquefied hydrogen carrier is already ready, and yeah, and from that location, the hydrogen is transported to Kobe. And by the way, the first import we have realized in February of this year. So 3 months ago, we have realized the first import.
So the hydrogen road is already there, actually. So the liquefaction stuff is done, the ship is done.
Yes.
And what other developments are there going to be in the shipping then, for instance?
For the shipping.
For the ship, yeah.
Yes. So we have started with a pilot ship. So for testing and demonstration. So the capacity of that ship is, of course, currently it's small. So it is it is something like 1,250 cubic meters storage capacity. But within our plans, we will quickly scale it up. So for 2030, we plan to build a liquid hydrogen carrier with 160,000 cubic meters capacity. So, and with 160,000, then we are in a range of LNG tankers as of today. And as I said before, we have more than 100 years experience in shipbuilding. So therefore, I guess within the next 8 years, we will have this huge ship. And with huge, I mean the length is more than 300 meters of that ship, 56 meters in wide. So then we have this big ships, because it is necessary. By the way, why we are going this liquefied way? Because you can imagine, for long distance overseas transportation, you need, or it is mandatory to go ahead with the highest energy densities. And of course, in hydrogen in liquid phase provides the highest energy density, and that's the reason why we go this way, or why we have to go this way. And of course, in the beginning, the liquefaction itself, it's energy consuming, yeah. But afterwards, then there is no additional conversion necessary, like other passes like ammonia, methanol, and so on. Therefore, we believe that we can. So we keep hydrogen as hydrogen. So no more conversion is considered within our road, and so we can also ensure the purity of hydrogen. So we have pure hydrogen. So no other let me say elements.
No reformers necessary. Hydrogen just stays hydrogen.
Yeah.
Okay. So that's the transport taken care of then, and then we have these hydrogen tankers arriving in Japan. You already mentioned the combined heat power plant.
Yeah.
And you know, the company you work at is Kawasaki gas turbine.
Yeah.
That sounds like combustion, not necessarily fuel cells, where a lot of people in this hall tend to go for fuel cells. So why does it make sense in this case not to go the fuel cell route, but to go for combustion?
Yes. Yep. Thank you for that question. Of course, at least it depends on your application. So you will have application where it would make sense to use fuel cells, but we have a lot of applications where you cannot use fuel cells. For example, our typical customer is the industry, and we're providing industrial gas turbines. So for our customers, they need electricity on one hand side, of course, but they need much more energy in kind of heat, and heat on high temperature. So the fuel cells, the operating hours, for example, of PEMs is around 80 to 100 degrees C. So you cannot use it. Maybe you can use it. You can produce warm water for shower or something like that. But that's it. Or for district heating. But especially for the industry, they need heat on high temperature for the processes, and they produce steam. And for example, for drying processes, or our typical customers are from the food industry, tire industry, chemical industry, paper industry. So, of course, all industries who need a high temperature heat, and this is a big advantage of gas turbines, with hydrogen fueled gas turbines. So we believe that fuel cells and gas turbines, they are not in competition. So it depends at least on your application. So there is room for both.
Different applications, different solutions.
Yes.
Okay. And with that, any questions from the audience, perhaps? If you do have a question, please raise your hand. There we go. That was a quick one.
Hello. Whoops. Just a question for the LH2 tankers or carriers. What about the boil-off effect? So if you say like from Australia to Japan, but if it's like longer routes, maybe from Middle East, how much hydrogen do you lose on the journey?
Of course, you cannot avoid the boil-off effect. We have that. So in our vision, we will use for the full commercial ship, we will use the boil-off effect. We will use this hydrogen for the propulsion of that ship. So it's in development. So the current pilot ship has it's still diesel driven, yeah. But for the future, for the full commercial ship, it will be this boil-off gas will be used for the propulsion of the ship. So that's this is the approach. And by the way, I would like to say some more details about our unique storage systems. So when we discuss about liquid hydrogen, then we are discussing about cryogenic hydrogen with minus 253 degrees C. So it's very cold. And within our storage systems, let me say, it's more or less a adiabatic system. And the heat loss is very, very low. I give you an example. When you store water with 100 degrees C, after 1 month, you are losing only 1 Kelvin. So after 1 month, you have still 99 degrees C of that water. So the heat loss, because our storage tanks, this is a double wall vacuum structure. And so the heat loss is very, very low. And this is also very special, developed by Kawasaki.
All right, so Kawasaki doing everything from producing the hydrogen to importing it to storing it, everything. All right, and with that, unfortunately, our time is up. I would like to thank you, though. So can I get an applause for Dr. Nurettin Tekin of Kawasaki Gas Turbine Europe?
Thank you. And more information, we have a booth over there. It's just...
it's number C40.
C40, yeah.
Yeah, it's over there. It's the one with the red. You can't miss it. Hessen, it says.
I am looking forward to get in touch with you. Thank you very much.